Welcome to British Biomedicine Institute. Today we will explore concepts in radiation physics and radiodiagnosis. Radiation is energy in movement. Electromagnetic radiation, EMR, refers to energy that travels in the form of waves. Another way of thinking about EMR is as a matterless bundle of energy called a photon. The photon is the package of energy that carries the energy through space. The other type of radiation is particulate, in which small particles, electrons, alpha particles, carry the energy. Particulate radiation can emanate from radioactive materials and linear accelerators. Particulate radiation is not effective for imaging due to low penetration of matter. Radiation interacts indirectly with DNA by first interacting with water molecules in the vicinity of the DNA, causing ionizations that result in the formation of free hydroxyl radicals. The free radicals can then diffuse to the vicinity of the DNA and can cause alterations in it. Observable matter is made up of discrete components known as atoms and molecules. Atoms are divisible into particles, such as electrons, protons, and neutrons. Other elementary particles are part of the fabric of nature, but they are more elusive, and do not directly form stable atoms or molecules. The characteristics of the various forms of EMR vary according to the wavelength. It is important to understand that frequency and wavelength are simply inversely proportional. X-rays, for example, have a shorter wavelength and higher frequency than visible light. When a particle, or group of particles, is accelerated, it can reach high energies and travel a large distance in a very short time. Radiation can be defined as any collection of elementary particles that have sufficient energy to interact with and transfer some of their energy to objects or materials that intercept their path. Some types of radiation can transfer energy in a manner that creates ionization in the object. X-rays and gamma rays are particles called photons that can create ionization. Microwaves, ultraviolet radiation, visible light, and infrared are also photons, but they do not result in ionization and are referred to as non-ionizing radiation. Ionization created by radiation in living systems can have unique biologic consequences that are different from those caused by non-ionizing radiation. When people are exposed to ionizing radiation from sources outside or inside the body, the radiation may interact with molecules in cells in their path. Some ionizing radiation can travel through a few or several layers of cells, beta particle radiation, or through many cell layers into and through tissues deep within the body, X and gamma radiation, whereas alpha particle radiation has short paths, or tracks. The rate at which radiation loses energy along its tracks is referred to as linear energy transfer, LET, and depends on its track length. Thus, beta particle radiation and the electrons associated with X-ray and gamma rays, which are sparsely ionizing, are described as low-LET radiation, and alpha particle radiation, which is densely ionizing, as high-LET radiation. Thank you for showing interest in British Biomedicine Institute Skilled Nano-Degree Program. Hope you have gained a lot of clinical information through this presentation. Please share, like, and subscribe British Biomedicine Institute channel. Good luck.